we'll see that what is the structure of atom, the rich diversity of chemical behavior of different elements can be traced to the difference in the internal structure of atoms of these elements. That's why we have to understand clearly the structure of atoms, because the internal structures of atoms of different elements behave differently. So today's learning will start with the discovery of electron and its characteristics. In previous class, we discussed about the Dalton's atomic theory. And Dalton, what he suggested, that the atom as the ultimate particle of matter. So with this theory, he explained the law of conservation of mass, the law of constant composition, and law of multiple proportion very successfully. But this Dalton's theory unable to explain the results of the many reagents as per experiments, because it is known that the substance like glass or ebonite, when rubbed with silk or fur, get electrically charged. So this fact cannot be explained by the Dalton's atomic theory, because Dalton suggested that atom is the ultimate particle of matter. So later, with lot of experiments, it is established that the atoms is made of subatomic particles, electrons, protons, neutrons, and this is the concept very different from the Dalton's, because Dalton's suggested the ultimate particle of the matter is atoms, but here we found the subatomic particles, electrons, protons, and neutrons from atoms. We'll focus on the electrons. An insight into the structure of atom was obtained from the experiment on the electrical discharge through gases. Before we discuss the results, we need to keep in mind a basic rule. What is the basic rule? That like charge repel each other and unlike charge attract each other. That means positive charge will repel the positive charge and negative charge will repel the negative charge, but positive charge will attract negative charge and negative charge will attract the positive charge. Now, Faraday studies an electrical discharge in partially evacuated tube known as the cathode ray discharge tube. You can see in this figure, this is the cathode ray discharge tube. So this cathode ray is made of the glass. This is the made of the glass, and with two thin pieces of metal. Here you can find one thin piece of metal, and here also one thin piece of metals, and it is called the electrodes, cathodes and anodes, and it is sealed. You see that this side and this side, it is sealed. The electrical discharge through the gases could be observed only at very low pressure and at very high voltage. That means if we put the electrical discharge through the gas inside, if its gas is there at low pressure and at very high voltage, then the pressure of different gases could be adjusted by the evacuation of the glass tubes. This is the vacuum pump. With this we can control the pressure of the different gas, and here we can input the high voltage. So when sufficiently high voltage through this applied across the electrode, these two electrodes, current starts flowing through a stream of particles. Then current will start moving as a stream of particles moving from the tube from the negative electrode. It is the negative electrode minus. This is the cathode. to the positive electrode, that means anode. And then these are called the cathode rays or cathode ray particle, because this particle originate from the cathodes. That's why it was called that time the cathode rays or cathode ray particle. And these cathode ray particles moves from the cathode to anodes if you put the high voltage. The flow of current from cathode to anode is further checked by making a hole. You can see that if we put some hole here and putting the tube behind the anode with phosphorescent metal zinc sulfide, you can see here. Here we will put one hole and we will put the fluorescent coating. Then what we will observe? When these rays, after passing through the anode, this will pass through the anode, and anode has hole also. So it will pass these particles through the zinc sulfide coating. Then a big bright spot is developed on the coating. Here big bright spot. You see that here some yellowish tinge is there. So this is considered as the bright spot. So whatever the observation from the result of the experiment, he summarized it. Number 1, the cathode ray starts from cathode and moves towards the anode. This is the findings. These rays themselves are not visible, but their behavior can be observed with the help of certain kind of materials. Here you understood that we put the zinc sulfide and we made in anode one hole, and then that particles move through the anode's hole and it reflects on the zinc sulfide to give some glow. Number 3rd point, in the absence of electrical or magnetic field, these rays travel in straight line. In figure it is mentioned. Number 4, in the presence of electrical or magnetic field, the behavior of cathode rays are similar to that expected from negatively charged particle, because this cathode rays behavior is like the negative charged particles, because it is moving from the cathode, that is negative electrode, to the anode, positive electrode. And whatever we know that negative particles is attacked by the positive charge. So certainly these cathode rays particles made of the negatively charged particles, and suggesting that the cathode rays consist of negatively charged particles, and which is now called the electrons. Number 5, the characteristics of cathode rays. Now we know it is the considered as electron, do not depend upon the material of the electrode. Whatever the electrode made of the material, it will not depend on that material. Whatever the cathode rays particle is there, electrons, it is independent of the material of electrodes. And the nature of the gas present, and also whatever gas inside is there on the tube, it will not depend on that. Thus, we can conclude that electrons are basic constituent of all the atoms. And with this fact, now we can conclude that the electrons, it is not dependent on the material of the electrodes, and also it is not dependent on the nature of the gas. So it is a basic constituent of all substances, materials, and of all the atoms. Now we will find the charge to mass ratio of electrons. So in the year 1897, British physicist J.J. Thomson, and you have to understand that with this concept that modern mass spectrometer is used on this basis of this principle. Whatever the 1897 the physicist J.J. Thomson has discovered. So this is very important. And the ratio of electrical charge, this E, to the mass of electron, this E will be the subscript, ME, by using cathode rays tube and applying electrical and magnetic field perpendicular to each other as well as the path of the electrons. So here you can see the figure and you can figure out here is the cathode, here is the anode, and here you see the some fluorescent screen is there. And now when only the electric field is applied, if you apply the electric field, the electrons deviate from the path and hit the cathode rays tube at the point A. This is the path, normal path of the cathode rays particles, but it is deviating and it is stuck in the wall of the fluorescent wall in the A point. And similarly, when only the magnetic field applied, the electrons strike at cathode rays tube at the point C, this point. Here also it is deviated, and this C point, it is strike. And how do you know how to strike? Because in every case the fluorescent screen is there, so fluorescent color, you can find it in this experiment. By carefully balancing the electrical and magnetic field strength, here you have to remember that if no electric and magnetic field applied, then this cathode is supposed to go strike in the point B. So by carefully balancing the electrical and magnetic field strength, it is possible to bring back the electron to the path which is followed in the absence of the electric or magnetic field. That means this point B. So we can adjust the electric as well as this is the magnetic. So if we adjust then field strength, then we can put this cathode ray strike to a straight line towards the B. So Thomson's argued that the amount of deviation, whatever deviation is there from B to A and B to C point, the particles from their path of the presence electrical magnetic field depends upon, number one, the magnitude of the negative charge on the particle. Greater the magnitude, the charge of the particle, the greater is the interaction with the electric or magnetic field, and thus the greater is the deflection. That means the particle has more negative charge, means more deviation or deflection will come from the straight line. The mass of the particle, lighter the particle, greater is the deflection. Now, first we consider the charge of the particle. Now it is the mass of the particle. The lighter the particle, the greater is the deflection. That means if weight is less for this mass, then deflection will be more. Number three, the strength of the electrical or magnetic field. The deflection of electrons from the original path increases with the increase of the voltage across the electron, because if we increase the strength of the electrical and magnetic field, then the particle will deviate more. That means will deflect more. And by carrying out accurate measurement on the amount of the deflection, that means these 3 points, that means the charge of the this material, this particle, and mass of the particle, and the strength of the electrical and magnetic field. These 3 parameters we have to consider, and if we check this and if we measure, then accurate measurement on the amount of deflection is observed by electrons on the electric field strength or magnetic field strength. And then Thomson was able to determine the value of the E by ME. What is the equation? E by ME is equal to 1.758820 multiplied by 10 to the power 11 C kg inverse, Coulomb per kg. Where M is the mass of the electron in kg, E is the magnitude of the charge of the electrons in Coulomb. Since the electrons are negatively charged, the charge on an electron is the minus E, we have to consider here. Now charge on the electron. How do you find? You can find the experiment in your NCERT books, unit number 2, part 1, and I'll give little bit shortcut of this. That this Millikan devised a method known as the oil drop experiment to determine the charge of the electron, because from the Thomson experiment we understood that E by ME, what is the value is there, then E, if we determine, then the mass of the electron also clearly we can determine. So for this purpose, Millikan tried with his famous oil drop experiment to determine the charge of the electron. And he found that the charge on the electron to be minus 1.6 multiplied by 10 to the minus 19 coulomb. The present accepted value of electrical charge is little bit different. That means digital point we put more, minus 1.602176 multiplied by 10 to the power minus 19 coulomb. Now the mass of the electron, Me, small m and subscript always E, was determined by combining these results with Thomson's value of E by ME ratio. So this is the calculation. You can find this. This is the E value. Now E value from the Millikan's experiment we know, and E by ME value already we know from the Thomson's experiment. So now the mass of the electron is the, after calculation, 9.1094 multiplied by 10 to the power minus 31 kg. I think up to this much you clearly understood. Today for the electron is the part of the atoms, and how do you calculate the electron's charge and mass by Thomson and Millikan's experiment.